Hi all. So in this lecture, we will see about Halsted software science. So this is an analytical technique to measure the size, development effort, and development cost of softwares. So he used some primitive program parameters to develop expressions for the following. First one is the overall program length, then potential minimum volume, actual volume, language level, effort, and development time. So based on the primitive program parameters. So those primitive program parameters you used were the following. First one was the eta1. It is a number of unique parameters used in the program. Eta2 is the number of unique operands used in the program. Then N1 is the total number of operators used in the program. N2 is the total number of operands used in the program. So based on these four parameters, four basic primitive program parameters, he estimated the length of the program, potential minimum volume, actual volume, language level, effort, and development time. And also he has mentioned what is this operator and operands, what are the meanings of these operators and operators. So we will just mention that operators and operators are similar to those things that we used in the programming languages. So even though he has given some guidelines for these operators and operands, for example, assignment, arithmetic, and logical operators will be considered as operators itself. For the parenthesis is considered as a single operator, or the block, if we have some braces for begin and end statement, for braces, opening brace and a closing brace, then it will be considered as a single operator. Then if then else statement, if there is a if else statement is there, that statement together will be considered as a single operator, or the while do statement will be considered as a single operator, or the switch case statement will be considered as a single operator. Then in the case of function call, the function call will be considered as a single operator. Then the function call, if we have some arguments, then all those arguments will be considered as operands. But the parameter list inside a function declaration, if you are declaring a function, if there are some arguments inside that function, those won't be considered as an operand. So those arguments will never be considered as operands. So like that, he has defined what is an operator and operand. Okay. So we will see some of the factors. So these are some definitions. So first one is the length and vocabulary of a program. So length of a program, it is defined by Halsted as like this. So it quantifies the total usage of all operators and operands in the program. So it is the total number of operators and operands in the program. So length n equal to n1 plus n2. So we have already seen what is n1. N1 is the total number of operators used in the program, and n2 is the total number of operands used in the program. So this gives the total number of tokens in the program. So length n equal to n1 plus n2. Then what do you mean by this program vocabulary? So program vocabulary, it is a number of unique operators and operands used in the program. So program vocabulary is given by eta equal to eta1 plus eta2. So eta1 is the number of unique operators in the program, and eta2 is the number of unique operands in the program. So this sum gives a vocabulary of the program. Then he defined program volume. So if we consider the length of a program, it depends on the choice of operators and operands used. So it varies from a programmer to programmer. So two programmers writing the same code, if you calculate the total number of operators and operators, it will vary. If you are given the same program, if two programmers are asked to write the same program, the total number of operators and operators for those two programmers will be different. So it would depend on the programming style, and also it produces different measures of length for essentially the same problem when different programming languages are used. So for writing the same program in two different languages also, the measures for this length will change. So in order to compensate that, what he has done is he calculated this programming volume. So programming volume he has considered to compensate that programming style and also the programming language. So programming volume is defined as V equal to n log eta to the base 2. So we'll try to understand what is this expression. So program volume V is the minimum number of bits needed to encode the program. So program volume means it's a minimum number of bits that will be needed to encode the program. So to represent eta different identifiers, eta is a unique identifier, uniquely, then at least log eta to the base 2 bits will be needed. So log eta to the base 2 bits will be needed to identify eta bits. So if the total program length is n, then it will require n into log eta bits. So this is the volume, V equal to eta log 2. So volume V represents the size of the program by approximately compensating for the effect of the programming language use. So for any programming language, this volume. So if we calculate the volume, it will be the total volume that will be required to store that program. It is the total number of bits that will be required to store the whole program. Then again, he defined another parameter, that is the potential minimum volume. So potential minimum volume is defined as a V star. So potential minimum volume V star is defined as the volume of most succinct program in which a problem can be encoded. Succinct program means the minimum number of lines of code that will be required to define a program. So it is a minimum lines that will be required to code a particular problem. So it is meant by, it is called potential minimum volume. So minimum volume is obtained when the program can be expressed using a single source code instruction. So that will be the minimum volume. If you could express the whole program in a single source code instruction, then that will be called as the potential minimum volume. So a function call like run or the main call, it is a single line of code. So it represents the whole code. So that represents a potential minimum volume. So if an algorithm operates on input and output data, D1, D2, etc., Dn, the most succinct program would be f of D1, D2, etc., Dn and semicolon. So if it is in C, it will be like this, f of D1, D2. So these are the parameters that will be passed. So if we consider this statement, this is the minimum line of code that will be required to represent some function. So if we consider this f, the total number of unique operators will be 2. So function call will be considered as a single operator. Then we have a semicolon. The semicolon will be considered another operator. Then if we consider the number of unique operands, then it will be D1, D2, Dn, all will be considered as unique operands. So here eta1 equal to 2. We have 2 unique operators and there will be n number of unique operands. So volume can be calculated as V star equal to 2 plus eta 2. So this will be the total length. So 2 plus eta 2 log 2 plus eta 2. So this will be the potential minimum volume of that program. Okay. So from this, why do we calculate this problem volume is we have to calculate the programming level because we need to compensate that programming style. So in order to do that, we have to calculate the program level L. So programming level L is given by L equal to V star by V. So program level is to measure the level of abstraction provided by the programming language. So it is a level of abstraction that will be provided by the programming language. So languages can be ranked into different levels based on this L calculation. So if we have a higher the level of language, then less effort will be required to develop a program using that language. So if we consider assembly code, then the level will be 1. So it means we require more effort to do coding in using assembly code. If the level is 4, it might be some object-oriented programming. So So it means we require less effort to do the programming in that language. So in order to determine that programming level, he has used this formula L equal to V star by V. Then he calculated effort and time. So effort is calculated using this formula E equal to V by L. So based on the previous V and L, we can calculate effort. Effort equal to V by L. Volume by level gives the effort. So effort is actually the number of mental discriminations required to implement the program. And also effort can be considered as the effort required to read and understand a particular program. So how much effort we require to read and understand a particular program, it is the E value. So it is given by V by L. So if we substitute the previous L equal to V star by V in this equation, we get programming effort E equal to V squared by V star. So that means programming effort varies as the square of the volume. So square of the volume. So programming effort is dependent on the square of the volume. And we can calculate time also. Development time. Development time T is given as E by S, effort by S. So where S is the speed of mental discriminations. So already this S has been calculated, has been empirically developed and from psychological reasoning, and it is recommended value for programming applications is 18. So we know the value of 18. So if we calculate E, then we can simply calculate this development time T equal to E by S. So this is the equations for effort and time. The next is length estimation. So length of a program, we have already seen. Length of the program can be found by calculating the total number of operators and operands. We have already seen that capital N equal to N1 plus N2. But that is not a good thing. So Halsted determined the length of a program using the number of unique operators and operators used in the program. So there is a derivation for that. You need not learn that derivation and all. So he has calculated that N equal to eta 1 log eta 1 plus eta 2 into log eta 2. So length, volume, cost, effort, everything can be determined even before the start of this programming activity. So that is a thing that you have to see. In Halsted software estimation, all these things can be estimated at the initial stage. Even though this Halsted estimation is good to calculate the maintenance effort, because maintenance happens after coding, everything is done. So we have the whole code and we know the total number of unique operands, operators, everything is known after completion of the program. So if we simply substitute all those values in these expressions, we will get the effort, time, everything will be, effort can be easily got. So it is very good in calculating the maintenance effort of a particular software. So that's all about Halsted software science. Thank you.